Now let's take our knowledge of finding resultant vectors and apply it to projectiles. Projectiles are things that have a horizontal velocity and a vertical velocity. And let's look at why resultant vectors are important for those. Let's say that we have an object that is being launched off of a table. And it has some velocity in the horizontal direction, let's say of 2.5 meters per second. If we ignore air resistance, the horizontal velocity of that object is constant. So we can say that the velocity in the x direction is constant. Why do I call that the x direction? Think for a minute about a graph. You've got an x-axis and a y-axis. We're looking at horizontal, so that's our x-axis. So you can imagine that when we talk about velocity in the y direction, we're talking about vertical velocity. Now the velocity in the vertical direction is not constant at all. What is influencing the velocity of an object that's falling in the y direction? It's going to be gravity, isn't it? So the acceleration due to gravity is going to cause the velocity in the y direction to increase. And so we know the rate of increase. It's 9.8 meters per second squared. It's g, if we're dropping something on Earth. Now for these problems, it's important to remember that we're ignoring air resistance, because air resistance would change it to some degree. This is why we think lighter things fall more slowly than heavy things on Earth. But in fact, in a vacuum where there's no air, they would fall at exactly the same rate. Mass has no impact on how quickly something reaches the ground. So why does this have to do with vectors? Well, let's imagine what happens when an object falls. We start to see this kind of a pattern. It creates a parabola shape, and there's a reason for that. At every point along this path, our horizontal velocity, our velocity in the x direction, remains constant. So in this case, it's always 2.5 meters per second. But let's think about what's happening in the y direction. The velocity starts out small and gets greater and greater and greater as it accelerates towards the ground. So in each case, what I'm doing is I'm looking for a resultant vector. And if you imagine these being tip to tail, then we would have a resultant vector that looks something like this. But as it speeds up, my resultant vector begins to turn more and more in the downward direction. The result is this parabola shape. So for any point in the path of the projectile, we're finding the resultant between the components in the x direction and the components in the y direction. Now it's important to note that when something has a horizontal velocity, even if we fire it out of a cannon, it's not accelerating. At that point, the force has already been applied and it's going to continue to travel at a constant velocity in the horizontal direction. The only acceleration that's occurring is in the y direction due to the acceleration due to gravity.